Good evening to everyone. So today we are going to see a presentation on ocean thermal energy conversion, an important topic in renewable energy sources. So let me share my screen. So ocean thermal energy conversion. So what is meant by ocean thermal energy? So when you see the layer of an ocean, so there will be a temperature gradient between the top layer and bottom layer. So there will be a temperature gradient. And gradient means difference in temperature. So ocean thermal energy system uses water from both these places. That is a hot sink and the cold sink with the heat exchanger principle. So it works to produce energy. So that is called as ocean thermal energy conversion. Right? So ocean thermal energy conversion, as I already told, uses the difference. Temperature gradient means difference of temperature between warm surface and cold deep water surface. The temperature will be warmer at top surface of the ocean and it will be cooler in deep sea. So it generates electricity using the thermal gradient of the ocean, and to be efficient, to produce efficient power, a minimum of 20 degrees Celsius difference is required between the top surface and the bottom surface. So it is based on a Rankine cycle. So I think we all know what is a Rankine cycle. So it is a cycle which consists of a boiler which produces steam and a turbine which is a prime mover which produces mechanical energy. The turbine produces mechanical energy. The shaft of the turbine will be connected to a generator, right? So which converts mechanical energy to electrical energy, and the remaining steam after power generation will be condensed in a condenser and then it will be pumped again to the boiler. So this is the function of the Rankine cycle. So in this part, warm water vaporizes low boiling fluid. So to produce steam, warm water is used in heat exchanger principle. So vapor produced from the low boiling fluid is used in the turbine to generate electricity, and cold water condenses the vapor back to liquid. Cold vapor is used to cool the steam, and condensed cold water is used in the condenser. So this is a schematic layout of a ocean thermal energy conversion system where cold water is used for condenser. That is, steam coming from the turbine has to be converted into water in the condenser. So the cold water from deep sea is used as a cooling medium to convert the vapor to liquid, and warm water from the top surface of the ocean is used to vaporize the cold water that is coming to the evaporator, right? And a turbine will be used for generating the mechanical energy. This shaft of the turbine will be connected to a generator. So the shaft of the turbine will be connected to a generator to produce electricity, right? So there are three types of ocean thermal energy conversion systems. One is closed cycle, which uses ammonia or similar working fluid, and open cycle, where seawater itself is the working fluid. That is, cold seawater will act as a working fluid as well as heating and cooling agents. Hybrid system combines both ammonia and seawater. So the components: intake pipes, heat exchangers, turbine generator, condenser, and pump system. So we will see what is the purpose of these components. Intake pipes to travel to transmit water. So this intake pipe is for transmitting water. Heat exchanger is used in two places. One in evaporator to exchange heat from warm water to the working fluid in evaporator to vaporize the working fluid. And another heat exchanger is used in condenser, where it is used for the water from deep sea, that is cold water, is used for condensing the working vapor. Working fluid which is converted to vapor has to be condensed back for next cycle. So in the two places, that is in evaporator and condenser, heat exchangers are used. And turbine generator is the prime mover which produces mechanical energy in this type of systems. And you already see condenser is for liquefying the working fluid, and pump is to increase the pressure of the working fluid as it goes to the boiler. So this is open cycle which takes cold water from the ocean depth and it condenses, and hot water is taken from warm surface water from the top surface of the sea is taken into the boiler to produce steam, right? And steam is sent to the turbine to produce mechanical energy, and the turbine shaft rotates and it is connected to a generator where electricity will be produced. So this is cold system where cold water and hot water from ocean is used only for heating and cooling purposes, whereas a separate fluid such as ammonia runs through the cycle. So how we will select site for establishing a ocean thermal energy conversion plant? So tropical ocean gradients where the thermal gradient, that is the temperature difference, is high, right? So that type of oceans has to be selected. Proximity to deep ocean. So the depth of the ocean should be minimum so that the proximity will be more, and depth should be less and temperature difference should be more. That is the major two conditions. And stable marine conditions, the aquatic life and aquatic plant life and animal life should not be disturbed, and it should be closer to a power grid so that we can minimize the transmission loss. So if the distance with the grid and the power plant is more, the transmission loss will be more. So it should be nearer to a power grid. So what are the advantages? It is renewable and sustainable form of energy as it involves open sea water and base load power. So the power is dependent upon the temperature gradient and it produces fresh water. So as the seawater vaporizes, it produces fresh water. Condensed water will be fresh water, and it supports aquaculture and reduces fossil fuel use. That is, the fossil fuel means fuels which will emit carbon dioxide, or fuels which are based on hydrocarbons. The usage of such fuels will be minimized. So high capital cost, the initial investment will be more, and the efficiency, that is the input power divided by output power. Here the input power is power required to run the pump and heat supplied for evaporation. So these are input power which is very high, and corrosion due to the salty nature of water and biofouling due to the same reason is one of the limitations. And environmental impact, that is as I already told, the impact on aquatic life is a major disadvantage. So byproduct, electricity generation, freshwater production, aquaculture, air conditioning, and mineral extraction for future. Aquaculturing means certain plants can be grown with the fresh water in the estuaries. So that is called as aquaculture. So projects are there in Hawaii, India, Japan, France, and Korea, and it is focusing on improving the efficiency and scalability. So presently, small scale projects are there. So efforts are being made on to improve the scale, that is, improve the capacity of the plants and increase the efficiency of the plant. Okay. So this is about the ocean thermal energy conversion. So it will be a good renewable energy which can be used without any fossil fuel use. The future focus areas will be on improving the efficiency and scalability, that is improving the capacity of the plants, right? Thank you.